Okay, so I've got the birthday thing all set to go here. There's one of the important things. What do you want to call that?
Gift location.
Gift location, sure, works for me. So there's a gift location. It's got 2 boxes in it. What do you want to call the first box?
Gift.
For now, we'll sort of cheat a little bit, and we'll just call it an actual gift, and we'll worry about making it more general later. What about the next box?
Next gift.
So there's the variable. What type of thing is it?
It's a memory location. So it would be a gift location.
We said that box is called a gift location. So this box is called a gift location. So the thing that makes that box refer to that thing is also called a gift location. Now, doesn't that look a little strange? Okay? But the thing to remember when you see that is that refers to the next one in the chain. Okay? So it's the same type of thing as the current box, but it refers to the next exact box on the chain, or the next thing on the chain, which is the same type of thing. Okay? This is why it drives computer science people crazy when they first see it. Okay, well, let's do the same thing that we've done with any other class, which is let's write a constructor for it. And we'll just keep track of the name of the gift. And for the next location, we'll start out and we'll always say that it's empty. And so we need something to fill that in. And you can see already that we're going to despise the word next by the time we're done with this. Now this is called get gift. The question is, do you need a last one? We're going to leave out the last one for now. We're going to do it the hard way, and we're going to suffer the performance problem, and then sooner or later it makes a good lab exercise to fix it. Okay. So there's the gift location thing. Let's write a driver program here. Main in it. And this was parents supplied the first one, I guess. Actually, I should be careful here. What's the first thing you see in the living room?
It's the first note.
Just the note that says, there's where the first gift is. Notice something special about that first note? There's no gift associated with it at all. It's just an empty note. Okay? So we'll make that one as just the start of the chain. And it starts out as an empty note. And now what happens is somebody comes along and says, the parent's gift is a new gift location that's got socks. And then what do?
Put it in the dryer.
They put it in the dryer, which is sort of meaningless here at this point, could be anywhere. And then what do after it's in the dryer?
Have the note point to the location.
They say start of chain equals what?
Equals parents. And then they set the next gift as this is the end.
Well, the next gift is already, the constructor already said next location equals null, so we're okay there. Let's just do the second one. We'll do a few of them and then we'll redraw the diagram. So now somebody else comes along.
Uncle.
Because he just came from the bar. And then what does he do?
And he sets the note of the socks to the location of his gift.
There's a couple of ways of doing this. You can either do it from following the chain, or you can do it if you happen to know who the last person was to actually put a gift on the chain, because they're sort of keeping track of the last. Okay? So let's just get a few on there by being a little bit smart about it, and we'll do parents dot set next location uncle. And maybe we'll do one more. Aunt trying to think of suitable gifts for an 8-year-old. And this would be uncle dot set next location to aunt's gift. Seems a little backwards. Let's put a breakpoint in this thing, see if my debugger will actually show me these things. So there's the parents with their gift of socks. Do a step over. There's the next gift is the uncle. And now watch what happens to parents' gift location when we do the step over. It gets set to the next thing in the chain. And now that thing has got a null in it. And we'll do it one more time. Step over. And a step over there, and now the next location in the chain is now got the chocolate bar. Okay? So you can see this in the debugger. The only problem that we'll find in the debugger is that sometimes seeing these things is sort of ugly, but all of the values are there. Okay? Just for fun, let's do it without the debugger, since quite often these things are a little easier to do on the board. So we start out with a start of chain variable that's just empty. The next line makes a new gift location for socks. And that's got the gift and the next in it. That thing's got some sort of address, we'll call it 600. That address gets plugged into the parents variable, and then that line copies the 600 that's in the parents variable into the start to do that. Okay. One more time, we make another new gift location that's got peanuts in it. We'll give that some other address. That gets placed into the uncle's variable, which draws that line. And then this thing says, the next line there says, take the value that's in uncle, which is 800, and put it into parents dot set next, which does that. Okay? So there's the chain forming. Okay. Suppose that I wanted to print out all of the values that are on the chain of things. How would I go about doing that?
You'd get the start.
Which is essentially playing the birthday game, right?
Yeah. Get the start location.
That's the piece of information I need. If I don't want to disturb that thing, I need a separate piece of paper to record that value so that I can figure out how to get onto the chain. So I'm going to need a scrap piece of paper that's going to say, let me copy that value so that I'm also all set to go play the game without disturbing that piece of paper. Okay? So we'll need a variable.
Trace.
And there's no good names for these things. Sure. Now, in computer science terms, most of the time, you'll see that variable referred to as current. That's sort of become the norm. So current starts out there. What would you do to print the first one? Just one of them.
Two string.
Current dot get gift. Okay, let's just run it and see whether or not that prints out the first one. There's socks. Okay. How about printing all of them? All of them means some sort of a loop. What type of loop? Well, you would like to use a for each, except a for each requires an iterator, and I don't think these things have iterators. You'd like to use a counted for loop, but
We don't know how many to count.
you really don't know. The kid has this no expectation of there being exactly 7 gifts. So we're left with, we're going to have to do this a whole bunch of unknown times. So there's that idea that a while loop is used for, I don't know how many times I'm going to have to do something. How would you know that you were at the end?
And next equals null.
So usually the easiest way to think of these is to think of, well, what if they were really cruel and there were no gifts? Okay, so if there were no gifts, then current would be null. So as long as it's not null, we can keep going. As long as there's something there. Okay, print out the gift.
And then set current to.
So now this is the trick here. So current has a 600 in it. We printed out the value of socks. What do you want that value to be?
800, the value of next.
800 is the value you want it to be. Where are you going to get that value from?
From the next. From the.
This is the variable you've got. This is the value you want. The actual thing that's holding on to that is current dot next, or in our case with the getter, current dot get next. Okay. So what we'll do is we'll grab the value of current dot get next. I guess we need get next now. So we're going to take that value and we're going to put it into what?
Current.
Okay, so take the value of the next thing in the chain and plop it into the current variable, which basically advances you by 1. Okay, so we'll save all that and we'll run that. And there's all of our items. Okay. So, important thing of this, anytime you're working with chains of things and you see something that looks anything like that line, current equals current dot next, that just means advance by 1. So that's the equivalent of I++ in a counted loop. It just means take a next step to the next thing that's under this chain of things. That's all it does. Even though it does it by grabbing that value and plopping it back into a variable that's already there. That's all it does. So don't be weirded out by it. It's just a perfectly normal thing to do. Okay. What if I wanted to, we've got this chain of things set up and then Granny comes along. How do we get Granny to cart the Harley all throughout the house and position her gift at the end? Well, okay, but we still have to play the game, right? And so the game is basically get to the end. Do we have some code that already does that?
Get next.
That code there, already one way or another, if it prints out chocolate bar, gets you to the end. Okay, so we're going to play the same sort of game with no print statement in it to get to the end. And I'm just going to leave that in there in case somebody wants to look at it later. And then what would you do?
Then you would set,
Current equals, granny dot.
Careful here. If this is the end one, then current is now sitting here at 800. We'll just pretend that this is the end one since I run out of board space. So current is advanced to sitting over top of this one. So what do you want to change?
so current dots set location to granny.
Current dot set next
Yeah.
to the granny variable. To set it. We'll give it a try. Oh, it died. And it died with a null pointer exception at that line. And the only way that you get a null pointer exception is if that current variable has got nothing in it. Why does the current variable have nothing in it?
Okay, so yeah, current's not null.
When this loop ends, the reason it ends is because current is null. And so by the time you get down here, that thing is null, and so you can't do null dot set next, which means that current here ran one too far and copied this null value back into here, which made that thing null. So when do you actually want to stop?
Yeah, one before.
One before, which is as soon as you see that current dot next is empty, then you know you have to stop, because then you're going to go current dot set next in order to tack the next thing on. Okay, so the only thing that has to change here is that thing, instead of running off the end, has to stop when it's underneath the one that you're interested in, which is while current dot get next is not equal to null. Okay, so we'll try that, and ooh, the null pointer is still there. Oh, sorry. No. What? No, it's got to be, well, it's not empty.
Or where you're assigning current dot next to current. You're assigning null, and then at that point, you can clear going up to null.
When in doubt, just make sure I've got rid of that breakpoint. Run with our friend the debugger. Let's look at the value of current. What's the value of current?
No.
Why is it null?
Because you're assigning get next, which is null.
Oh, you didn't reset it to the beginning.
Didn't reset it to the beginning. Okay, so it shouldn't be null at that point. Let's just go back and look at the bigger view of the code. We ran this loop, which wiped out current. So if you're going to use it again, you need to set it back to the beginning so that you can go through and do it all over again. Okay, so that variable had run off the end. Okay, by the way, there's another joy of using the debugger, right? Everybody's focused down on this piece of code going, I don't understand what the problem is, we must be out by 1 here someplace, when actually the problem was the fact that before we even started, we were wrong. Okay, so the debugger is almost always your friend in a lot of those cases. So there's all of those items, except now we have to do this loop one more time if we want to see all of the stuff. So let's just take all of that stuff and do it one more time. And now we should hopefully see all of the things, including the Harley, on the list.
Where's socks?
Oh, it's just scroll up a little bit. I'm just not showing it there.
Oh,
There's socks. So there's all of the items. Okay. Notice how painful that is.
But if the first loop we write as current.get next also, so that we don't have to write current if we want to start a chain again, printing the eggs twice, right?
You have to always reposition yourself back to the beginning in order to go through. The first loop prints them out, but then it ends. Then we have to reset it so we can add something, and then we reset current again because we always need to start at the beginning. Okay? So notice that a whole bunch of this code now starts to look the same. Okay? So this code here is really what you do to add to the end. Okay? So that's really add. And some of this is for other stuff. Okay? Get is basically the same trick, except you have to count how many times you have to go instead of always going to the end. Okay? So what we're going to do tomorrow is we're going to take this idea and we're going to say, oh, it's too difficult to manipulate these chains all the time by hand. Why don't we take all of the API that with the interface that we had for the list that we just built, and we'll replicate the exact same get, add, count, all of those sorts of things into a class that keeps track of the chain for us. Okay? And then we'll have two storage mechanisms. You can either store things in arrays of things, or you can store things in chains of things, each with different performance things. Okay? So we'll generalize that thing tomorrow now that you see how it works. And with that, we're done.